Hello students, welcome to Samclasses. Now the PYQ section was a bit delayed, but we'll finish up everything by 8. Now before starting the PYQ, we wanted to talk to you. We wanted to explain you a few things which were not very proper. Now the questions and the book. See, we only have one book for the PYQ section, and that is the MTG publication. And here and there papers are available of that book. Scanned copies are available of that book, but that book is not correct. So let me again conclude it that book is not correct. We checked with all the past papers from 2020, 2019, 2018. They have given rubbish. Sometimes they have pulled from few questions from KCT. Few they have pulled up from Jammu Kashmir KCT, from Odisha JEE. Something somewhere or the other they have pulled up. Not one or two questions are correct. Okay, very rare. Like in what you say in whole of 2020, they have given 4 or 5 questions and one or two is correct max. In some part, it is none correct also. Okay, so don't have a lot of faith in that book. If some question is very difficult, understand it is not of the COMEDK. So very first and very important warning which I want to give it to you all. First thing is we know already COMEDK is like 1 minute, 1 marks. So the questions which I have seen from the all together, okay, of the COMEDK is like all of them is either categorized into two parts. One is formula based or direct, you can say DC, direct application. One is a bit, a very minute bit. Like one is you can say direct application, formula based, and the other is full mug up. Okay, so not much of the brain is required here. A lot of questions where the values which we used to what is neglected, they wanted you to know it. Okay, in the COMEDK 2020 or 2019 paper. So what we saw. So you don't have to be what you say go through the JE questions. So whoever is going through revising and all that is wrong. JE wrong. Direct formula based questions, yes. Okay. Direct formula based questions, yes. Now things which you need to remember and mug up and get the values correct. Okay. So very simple. First of all, understand very simple questions are coming. A lot of students they have lost hope. Don't lose it. First of all, COMEDK comes up very easy. Whatever the videos and the materials which we are providing, that is more than sufficient. Okay, to understand. If you understand it and what you say, if you practice it properly, you'll be able to do most of the questions. Few questions are like proper mug up taken from the different parts of the chapter. So there you need to memorize, otherwise you won't be able to solve. So apart from that, rest of the questions you can easily score and easily get good marks. Okay, clear everyone? Now let's see. Now this is one of the books question, okay, which we have picked up, but this question is not there in the 2020 paper. Okay, but still, since we wanted to show some of the questions are like okay level, so we can practice. It's good for the practice. Since you have already bought the book and now there's no time, so there is no point in what do you say creating a havoc or like a what do you say a situation where you are like full anxious, you don't know what to do and all that. No need. Whatever you have from that, anyway, it is questions. Okay, from that you can practice. So just like a mock, you can keep in this book. The PYQ, I'll try to as much as what we have, at least 2019, 2018, 2020 papers we have. Okay, we'll try to provide. If anybody has actual papers from 2015 to 2020, do provide the link or do put it in the description or do put it in the comment section. Okay, so that will be very good, very helpful. We'll try to make a video on that, the chapter discussion and the paper discussion. Okay, so as of now, whatever we got, or you can join our WhatsApp group and the Telegram group and you can put it there. Okay, now you can share with us and we'll try to make a video so that each and every one of all the COMEDK students, all the aspirants of COMEDK, they're able to benefit from that, they're able to understand, they're able to solve it, and they're able to do it. Okay, now see this question, how do we attempt it? Okay, very simple question. A charge of this much coulomb is divided into two parts. So one charge you have divided into two parts. Okay, so very simple. If let's say one charge is q1, the other one will be what? 0.8 minus q1, correct? One will do by traditional method, one will try to see some short tricks. Okay, now, so force and the distance between them is how much? 30 centimeter. Force is equal to what? K Q1 into 0 0.8 minus Q1 by R square. Now what they've asked is, I'm not putting the values, understand next. Next they've asked force is maximum. Okay, the force on Q1 charge is maximum. Now, whenever we want to find maximum or minimum, what we do, everybody knows, we differentiate, correct? To find maxima or minima, what we do, we differentiate. That's very simple. So everybody knows that, so let's differentiate. But a lot of times students has the difficulty, sir, by what we should differentiate? Sir, we know this distance we are not changing, correct? Sir, we know, sir, this K is constant. Sir. So what is left? This Q charge only. So basically we're differentiating this force with respect to this Q charge one, correct? Done. So that is equal to K by R square. Now what about differentiation, sir? Differentiation will be very simple. 0 0.8 Q1 minus Q1 square. Let's say I've not differentiated here in the first attempt. Okay, though I have written df. So let me write d by dq of this whole thing. Okay. So what I'll do, let me just increase this size. Okay. So what will happen is here K by R square is constant. Just remove it, and that has to be what? Equal to 0. So we don't care about this. What we care about this part only. Correct. This is Q1 square. So what we'll get? 0 0.8 minus 2Q1 is equal to what? 0. So Q1 is equal to what? 0 0.4. Correct. Yes or no? So very simple. What we should know, a bit of the maths, we should know that if something whenever we are talking about maxima or minima, then what we talk about, that the derivative of the function with respect to whatever we are differentiating should be equal to 0. Okay, clear? Here in this case, the charge was there, rest all was constant. Clear everyone? If anybody has any doubt, you can give me a call directly. You can join our WhatsApp group. You can share your doubts there. Join our Telegram channel, share your doubts. And on 11th, we are having the mock. So please do join it. 11th and 12th will have the mock. Okay. Now, so by doing this much, a bit of minimum differentiation done. So question was very simple. Now what about if we try something else? Let's use a bit of brain. Now, force we know is equal to what? Everybody knows, sir. We all know, sir. K Q1 Q2 by R square, sir. Correct. Very good. So K is constant, R square is constant. So forget about these two. So here, force is directly proportional to what? Q product of Q1 and Q2. Correct. Now understand, if I have some quantity, let's say two charges are there and their sum is 10. When can their product be maximum? Understand, two charges whose sum is 10, when can their product be maximum? When they're divided into half? Correct. When they're divided into half, let's say 5 and 5. Because if I multiply these two, what I'll get? 25. Now if somebody will say, sir, what if we break this charge, sum of charge, which was 10 coulomb, let's say, into, give one charge as 1 coulomb and the other as 9 coulomb? I'll say, sir, what is the product now? Because see, in force, when I'll use it, I have broken the first charge as 1 coulomb, the other charge as 9 coulomb. So the force I'll get as what? 9 only. Correct. Q1, Q2 value is 9. So that is very small. Correct. What if, sir, if we break one a bit less than half, one a bit more than half? Again, we'll get 24. So means if I have a sum of charge and that is equal to 10 or whatever value, if I break it into two equal halves, then the product will be maximum. So this is a shortcut. Let's say if they would have given you some different value, let's imagine some value like zero point 0.4. So directly what you could have written, so the answer will break this into half, half, 0.2, 0.2. If they would have written, let's say we have 210 coulomb. So directly we can write half of that, half of that. Correct. 105, 105. So we need to understand the way things are. So this will take not more than 30 seconds to solve it. Okay. Clear. So the maximum of any, or what is if two things are added, we know that value is fixed. Okay. If the summation of two things is fixed, the product always lies in the half values. Okay. The max of the product we get it when we do it half half. Clear everyone? Okay. The same thing we can use in the concept of gravity also. Like force, is directly proportional to what? M1, M2? Correct. So if the mass of two objects is like 500, how we should break it so that the gravitational force between them is maximum? Okay, so 250, 250. Correct. So see, if you understand, you can solve by one question, understanding the concept, millions of questions. And if you just run after questions, sir, more questions, and you don't understand, you mug it up. In exam, you won't be able to use it. So do less questions, but understand them and do. And if you're able to do more questions, do it by understanding. Clear, everyone? So try to understand and then do it. And still after that, if you have doubt, do give what do you say on the comment section. Do comment it. So this part I'm having doubt. I'll again explain. Don't worry. Okay. Now coming to the next question. Electric field, electric dipole is there, plays in uniform electric field. Okay. We already know this. You should remember this diagram. Correct. Electric dipole plays in uniform electric field with the dipole axis making an angle theta. Okay. Some dipole is there making an angle theta here. Okay. The orientation of dipole is stable. See, dipole torque formula is what? The orientation of the dipole for stable equilibrium. Now, for stable equilibrium, torque is equal to how much? It should be how much? Think about. First, we know net force is zero, correct? Force F and this force is F is zero. We know force net is equal to zero. So what is the other force here? The other force is the rotating force, that is torque. And torque is given by the formula is equal to what? P sine theta. When is sine zero? When is sine minimum? At zero. So put zero. So what will happen? At theta equal to 0 degree directly. Correct. So we have seen a lot of questions coming from the dipole. Okay. So if you understand the concepts, you'll be able to solve. But a lot of students they have difficulty, sir. What do you mean by stable equilibrium? So let's just clarify in a very small example. Let's say we have taken a ball like this. Take a small ball. Correct. Now what do you do? Come and give a kick. Let's say you're coming and giving a kick to this ball. So this ball will go up, but again come down to its same position. Or you come from this side and give a kick. Again, this will go up, but come back to its same original position. So what you understand, even if we are applying some external force, after the removal of that force, what happens? It comes back to its original position. So that is mean by stable equilibrium. Clear? What about unstable? So since you have already told about stable, what about unstable? Now a big earthen ball is like this, okay, and you're coming from here and kicking. So the moment you kick, will the ball ever come back? It will go down. Or if you kick it from this side, it will again go down. Correct. So you need to understand the concepts and you need to solve it. Okay. This again is not there in 2020. So this part is the theory part which I've given in the concept videos. Do watch the concept video where you'll be able to understand, okay, what is force, what is dipole, how things are there. And this part of the dipole only for showing you and for explaining you what is more important from this chapter. A lot of questions have been picked from dipole. Their stability, where they're stable, where they're not stable. Okay. Now, and one more part, this part also they have taken a lot of times. Okay, students understand dipole in non-uniform electric field. Okay, like in uniform electric field, what were the things happening? So understand like this. Uniform means we show by straight lines. Okay, so uniform electric field, what happens? Force is net force is zero, torque is there. If it is non-uniform, net force is also not zero, torque may or may not be zero. Okay, so that depends. So most of the case, you'll get net force and net torque. Okay, clear everyone? Now, what we have here is this is an actual 2020 paper. So see how easy the questions are coming. Okay, and a lot of students, again I'm telling, the questions coming in the COMEDK is very simple, very easy. Try not to be disappointed, even if you haven't done anything till now. Start doing from now. It's way better than wasting the time what you have right now. Live in present. Don't be a prisoner of the past. Whatever happened in the past is done now. You can't change it. Whether you start crying whole day also, you'll be wasting today's present also. Correct? So there is no point in what you say, thinking about yesterday you wasted the time, or day before, a whole year you wasted. Right now, what you have, work in that. I've already told you the chapters are are important. Go through them. How much you can do. See, let's say today, right now, if I write a mock, I'll get 0 out of 0. Very good. Let's say today, if I write a mock, out of 16 physics, I'll get 0. But Today is which day? 6th. From 6th I started studying. 6th I studied damn good. 7th I studied. 8th I studied. 9th I studied. 10th I studied. 11th I studied. See, 12th I studied. 13th I studied. 14th I gave my COMEDK. And on 14th, let's say I scored somewhere around 30. So won't it be a damn good score considering you just started in like and studied this many days? Well, so sir, a lot of things, sir. The college which we wanted to appear, which we wanted to get, that won't be getting. So that you should have thought a bit earlier, sir. When you were wasting a lot of time and that to a whole year, so that still time is there. Okay, for that time you didn't think about that. So now at least it is way better than scoring a zero in paper. So from now onwards, also, if you reflect that no, if I'm wasting time today, that will have a serious repercussion in the future. So try not to waste time. Whatever, I'll give you a guarantee, whatever upcoming exams will be there, you'll be doing damn good. Okay? Because see, this is a habit. If today also I'll say, okay, tomorrow, next 14th, I have very less time, I'll give up. Then this giving up attitude you are bringing up. Don't bring this habit. Okay? Now, next part is let's see this question. So what we have in this question is, students, understand, two small spheres carrying a charge. Okay, see, we have two spheres. One is carrying a charge, let's say, plus 8 microcoulomb. Other is carrying a charge minus 6 microcoulomb. So we know force is directly equal to what? K, Q1, Q2, so plus 8, minus 8, forget about the value, by R square. So here force is directly proportional to what? Product of the magnitude, and that is equal to what? 48. Here minus 48, let's say. Correct. Second scenario, what is happening? You're adding a charge of minus 2. So add it to both of them. Now what will happen? This will become plus 6 microcoulomb. 8 plus 8 minus 2 will be what? Plus 6. And this will be minus 6 minus 2 is equal to what? Minus 8 microcoulomb. Now again the force will be what? Minus 8 into 6. So that is equal to what? Minus 48. So see, is the value of force changed? Illa. So answer will be what? 1 is to 1. Was it very difficult question? No, sir. Then why are you all getting scared? Understand the chapter. Concept videos are very, very, very important. Solve the whatever proper PYQs we have. We'll try to upload, solve them, and re-revise again and again. Okay, very important. So don't give up hope. We are fighting till the last day. We should keep fighting. Next, 2019. Okay, actual question. Let's see. A very simple question. Again, this also. Okay, if we try to solve it, we'll be able to understand and we'll be able to, what do you say, do it. Okay, just 1 second. Let me take this part only. Okay, so this part of the diagram, I'm just repasting it like bigger way because a lot of students they said, sir, diagram drawing will take time. Okay, so the picture was not coming very clear. The question I had to expand. So this one, I think so everybody will be able to see. Now understand they've given 2 point charges, Q1 and Q2 are there, separated by some distance r. Okay, so one here is Q1, one here is minus Q2, one is positive, one is negative. They're separated by some distance r. Now the magnitude of Q1 is less than Q2 means Q2 is bigger. Okay, this one is, let's say, so in this kind of questions, no, just put up some value. So you'll understand more better. Let's say minus 100 coulomb charge, and here I have plus 50 coulomb charge. Correct. Then simple. Next, we have to find neutral point. So see here at this point P, okay, let's say we are placing a positive charge. Somebody, sir, what about negative? Same thing it will behave, okay? Doesn't matter. Let's say we have placed a positive charge. Okay. So what will happen? This positive will push it that side. Very good, sir. Force. Correct. This negative will attract it towards that side. Correct. Now, if somebody would have taken a negative charge and thought, then what would happen? This negative would have attracted this side, and this negative would have pushed. So there is no point because see the forces are getting added. They're not getting subtracted. So neutral point where we get if the net force will become what? Zero. The point where there is no force, that is the neutral point. Correct. So here force will be there. Correct. So this is not correct option. What about the second one? Okay, sir. Same thing, sir. You made it a bit more this side. Correct. More towards this charge Q. So anyway, again it will be added. Maybe the magnitude will differ, but it will be added in both cases. For plus also, for minus also. Let's go for plus only. Otherwise, students will get confused. Means we are putting, if I putting a plus charge here, this plus will push it that side. and this negative will try to what? Attract and what? It will pull it toward itself. So these two, both the force will be added. So again, not an option. Sir, what about the third one, sir? Okay, let's see at this point. So let's say you're putting a plus charge here. This is minus. Plus and minus, what it will do? Sir, attract, sir. Very good. It will attract. What about this plus? So this plus will push it that side. Correct. Plus and plus, they repel. But now you see, this one is a smaller force, 50. This one was 100. This attraction, and the distance is also small. So this attraction force is way, way, way bigger than the repulsion force by this positive. Okay. So here also net force won't be zero. Correct. Why? Two reasons. First, the charge one was bigger and the distance was also less. Okay, so this whole force by the negative is bigger than force by the positive. So it won't be able to cancel. Now, what about this situation, sir? See, this positive is trying to repel that side and the negative is trying to attract. Now, negative charge was big. Okay, but since the distance became what? Very big. So what will happen? Force is directly proportional to charge. So charge was big, force became big. But it is inversely proportional to radius square. So if this increases, this decreases. So what will happen? The negative force here, they have the chance to be equal to the force positive. And we can obtain a neutral point here. So everybody got the idea how we are doing? See, no such thing like a very complex concept or JEE question it is this, okay? Clear? Very simple questions, no need to be scared. Very simple questions are coming, okay? Now coming to the next question. A charge Q is placed at the center of the line joining two charges, okay? So at the center of the line joining two charges, let's make it out. Nothing is there. One charge Q, again one charge Q, at center C, we have put up, let's say small charge Q. Let's take the whole length as L, so this will be L by 2, again L by 2, correct? Now, if something is in equilibrium, then what will happen? This point is important, okay? So it will be in equilibrium. The system of the three charge will be in equilibrium. So three charges are in equilibrium. Means what? The net force on any one charge, if you take the net force, will be zero. Let's say for this point, let's make some names A, B, and C. So the net force is what? Zero. So net force means the force on B due to A plus the force on B due to C equal to zero, means whatever the force this is putting up and whatever the force this is, if I add up all, it should be zero. Correct. Now, what is the force formula? K for this one and this one for force AB, for the AB force, okay, this big one. So it will be what? KQ square by L square. Correct. And for these two force between these two particles, one capital Q and one small q, it will be KQQ by L by 2 whole square. Correct. That has to be zero. So let's cancel K, 1Q will be cancelled. Okay. So what we got? Q by L square plus small q by 4 small q by L square equal to 0. Now L square also what? We got this. Now what will happen? L square also we can remove. So what we are getting? Q is equal to minus 4Q, or Q is equal to what? Minus Q by 4. That's it. So was it anything difficult or anything very complex? Simple. But you should know if the charges are in equilibrium, what happens. If you know this much, you'll be able to solve the question. So very simple question, you need to understand. You shouldn't have to write this much all. Okay. In exam, if let's say I'm a student, so what I'll write? Okay. Though since they are all three on equilibrium, so take any point. Okay. These are all things you should think in your brain. Take any point. Okay. At this point, let's say all the net force I have to make it zero. So what I'll write? Okay. Q square by L square plus QQ by L square. Okay. 4 equal to 0. Oh, L square gone. 1Q gone. Okay. 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 So Q is equal to minus Q by 4. That's it. So it will not take, it will be just less than 30 seconds, students, okay? So you need to understand that much. See, for the explanation, I took it so that you understand in more proper way, okay? Let's see the next question. Two positive charges equal in magnitude are separated this. What is the location of electric field to be zero? See, positive, positive. Can here it be electric field zero? No. Electric field is equal to what? KQ by R square. Now this one, or you can say force by charge. So can this force be zero? Here, no. Because for this positive also it is pushing that side, for this positive also pushing that side. Not possible. For this side, again same thing, both are pushing that side, not possible. What about at the center? We know if positive, like what do you say, at the center, what will happen? This will try to push that side, this will try to push that side. So at the center, this point I think so is not drawn properly. Here it will be at the midpoint, okay, 2. At the midpoint 2, this will be exactly 0. Okay, the net electric field strength at this point will be 0 because the electric field due to this one will be cancelling the electric field due to this one, but exactly at the center. Okay, I think so in the diagram they haven't taken properly. Okay, so this will be at center. Clear? At this 3 point again it won't be because this the electric field due to this will be what less in power and this one will be more, so it will be more dominating towards this side. Okay, clear everyone? So see, basic concepts they're asking students. These are actual questions of what is a PYQ of COMEDK. Basics questions they're asking. But you need to keep all the chapter, like all together, you need to remember everything. Okay, so revision should be must and you should be fast. Clear? Next question. So this it shouldn't take time. Electric dipole of dipole moment this much is what is enclosed by closed surface. What is the net flux? So flux, the moment they say flux means what? Gauss law. Flux means what? Gauss law. So what is phi? Charge enclosed by, sir, epsilon naught. For a dipole, how much is the charge? Net charge is what, sir? Sir, for a dipole, sir, if you put inside dipole, whatever positive, whatever negative, net charge is equal to what? Laddu, sir. So it will be 0, no, sir. See, a lot of students, oh, sir, this 20 is there. Some values will come. Okay, 1 point, sir, they have given. Nothing is there. No. Gauss law means charge enclosed by epsilon naught. Charge enclosed is how much for dipole? Dipole is what? I told you, two equal and opposite charge separated by some distance, equal and opposite. If I add net, 0. Clear? Next, electric dipole. See, I told you this kind of question comes a lot. Electric, I explained you in the concept only. Electric dipole is kept in a non-uniform electric field. See, if I keep it in uniform, understand this. Both, if you understand both together, this is uniform. So if I keep it in uniform electric field, let's say this is my dipole. So here also a force will be there. Force I know is equal to what? Charge into electric field. Correct. This side also charge into electric field. Now if you see both charges are same, dipole, equal and opposite charge. Electric field is also same because uniform. So F net equal to what? Let's do. Yes or no? Torque is here. Torque net is there. And what is the value? We don't know. Torque net. That is P crossing. Correct. P sin theta. What about non-uniform? Let's denote non-uniform like this. Okay. So non-uniform we have like this. Correct. So if we see in this for this case non-uniform one. Okay. If I make a dipole like this, here force will be F1, here force is F2. Now this sir you wrote F here, here, F1, F2, why? Because see sir, F1 is equal to what? Charge into electric field at this, because it is not same. The electric field here, the electric field here, the electric field here is what? Not uniform, so not same. F2 will be what? Charge into electric field 2. So here F net will be some value. It will be F1 minus F2 or F2 minus F1, whatever it is, whichever way direction you take it. But it will be, so force will be there. Proton is nearly this much times more massive than electron. Now they've given the Coulomb force of repulsion between two protons, plus and plus, some value that is F. Now they're asking what about electrons? Okay, between two heavy protons, which is almost 2 times heavier than electron, the force is what? Electrostatic force is what? This much F. What about electrons, which are like 1 by 2000 times less heavy? So first you ask, what electrostatic force depends on what? Does it depends on mass? Illa. Force doesn't depend on mass. So force will be same, no? Both the case. Because charge wise, magnitude wise, I know the charge of electron mod value is equal to what? Charge of electron proton mod value. Correct. The sign will be different, but the magnitude wise same thing, no? 1.6, everybody knows this value. Correct. So the force will be same. This is also not an actual question, but since we didn't get the 2016 paper, so whatever was there in the book, We have taken it. We have tried our best. So that's why a lot of delay happened. We tried searching everywhere. Everybody has given bogus question papers only. So we tried. If anybody has, do put it up. Okay.